Actually, what we want to do, I want to let you understand how to correct distortions as a result of projection from your WGX to UTM. Most of our work are actually done in UTM and other things and all. Most of the time you build from WGX down to UTM. But in that, you find out that your coordinate system are distorted in kind of the boundaries are not are forming the way they should form. When you bring them to UTM, I'm going to show you what happens and how you're going to do that. For example, you are giving coordinates, these 4 coordinates. You are giving these 4 coordinates in WGS 84. You understand? Then this is a boundary 0, 0, 15 here. If you look at this boundary, this is 5 here. Let's assume this is 5. This is 42. 42 here. 40. 40. And what we have here is 30. 30, 0, 0. Now, if you look at these coordinates here, these 4 coordinates, these ones are your longitude. Actually, your longitude. These ones are your latitude, which is the y-axis, the x-axis. If you look at the coordinates, you can see that this coordinate forms a boundary. It forms a boundary. You can see 39, 15 here, 39, 15 here. You can see 844, 0, 844, 0. Here also, 542, 30, 542, 30. 5, you can see they are in pairs. So that tells you that this forms a very clear boundary. Now, you want to plot this. We're going to use Global Mapper and we're going to use AutoCAD to do the correction. Then, let's assume I give you this to start working in using ArcGIS. I want you to plot this, or maybe for you to start map production with this boundary in ArcGIS. And normally I want you to start everything in UTM. What do? For example, this, as you can see here, you can actually change it to degrees. Our usual way, divide this by 3600 plus what? This. Divide by what? 60 plus what? This. Is that? Enter. Then you drag it and you copy and you paste here. You have the same thing, right? Okay. So you copy. You can still paste it at special or value. Okay, the same thing. So you can remove this. You can remove this. So you now have, what do you have now? You now have your X and Y in degrees, right? This is what you have. You can save it as CSV, right? Save it as CSV, call it boundary correction. You understand? Sorry, so let's just save it. Boundary correction, this is what we have. We'll save it, right? Then we can plot this in Global Mapper. We can close that. Okay, this is Global Mapper now. If we bring that into Global Mapper application, this is line, this is point. We want to plot it as line, right? Now skip, we are skipping the first one, right? 0, this and that. What else do we? I think that is okay. The only other thing here to correct, we say okay. You see, it assumes geographic latitude longitude system and it's in WGS 84. Okay, let's remove this the grid, no grid. You see, that is the boundary. You see, it has plotted. You know, it plots, this plots only for 1, 2, 3, 4. We didn't close it. We could have closed it if we had added the first one. So if we go back, I will add this one down here. It means we'll now close it, right? We can save and bring it back again, right? Okay. Save. So we can remove this, close this, and bring it in back again. Open. That is it here. We'll plot it back again. You see, it's closed now. We can see that this is a very perfect rectangle. The line is not distorted because it is what? It is in the original WGS geographic. Is that not true? But you want to project this now to UTM. What happens? Let's project it to UTM. Projection to UTM. You go to projection and put UTM zone 32 and you apply it. Okay. It has what? What happened? It has done the projection. But to you, if you look at it now, there's a kind of distortion on the line. You might not notice it here. Yes. Now, let's take this away. Let's export this to AutoCAD. If you export it as vector, you export it as vector data. It's a vector data, not raster, right? Export it. Let's export it as DXF file. We export that DXF file. We can just put it here on the desktop again. Boundary correction. Now it's a DXF file. Okay. It has gone. Let's see. It's in desktop. Let's export it again. I didn't know where we exported it to. DXF file. We can use boundary here. See the whole of this boundary. Okay. Is that okay? Is it here that we saved it? It is there. Okay, it's on our desktop. We'll open it in AutoCAD. It's the DXF file now. DXF file is AutoCAD file. Then now we now say, if you can't see it, how do you see it? It's not appearing. How do you see it? You now Z, you enter. When you say Z, enter, you press Z, means zoom. Now, when you say Z, enter, you look at here, it will show you all, center, dynamic, extent, previous, scale, window. What you want is extent. You press E again, enter, it will appear on the window. Listen it. So that zoom means zoom to extent. That's why I said Z, enter, E, enter. You understand? So it will now zoom to the extent. No, if you look at this now, this is what it takes. You can see. Now there is something I want to show you. If you go to AutoCAD, I'm sorry, if you go to here, the global mapper, you look at the boundaries. Let's look at the vertices. Look at the vertices of this. You see, if you look at the longitude, latitude, you can see that they are in pairs. They were not actually distorted, right? You can see 5, 4, 2, this and all that. You're supposed to assume the same thing here. in your X view projection and your Y view projection. If you look at this now, 461,706, 461,703. Have you seen it? 470472. Have you seen that distortion? There is no pair. You get what I'm saying? So how do you do that now? You need to now correct this. You see some of this distortion. The same thing here. 630974. Look at here. Here is 970. While here is 974. Instead of having 974 and 974. You get it? Now, so the only way you can do this is just pick your rectangle here, because you are supposed to have a perfect rectangle. Is that? When you pick your rectangle, you snap here. When you snap here and end here. Have you seen it? Now, for you to see the extent of distortion, you can zoom in. Have you seen the extent of distortions? Have you seen the differences? Have you seen it? Have you seen the differences? So this is how you can, from here now, you can generate the right coordinates to make your map in UTM. Have you seen it? So it will only align here, but here, towards the eastern boundary, it will not align. Have you seen it? The same thing here. So what do you do now? You can remove the old one. Which one is the old one? The distorted one. That is this one. You know, we're supposed to have used red. Let's use a different color. This one.
So the red one is the one you...
Yes, the red one is the new one. Is the corrected one. Have you seen it? It will align here. You see it? So that is it. Now, if I remove this, I can even make inquiries and see lists. You see? Let's pick the old coordinates. We can pick the old coordinate and see what they look like. That is the old coordinate. We can paste it here. That is the old coordinates. Then the new coordinates, make a list. This one, we'll go to tools and make inquiry, make a list of it. Is there something you've noticed? Have you noticed something? Okay, let's assume I put it here so that you understand clearly. Now, let's put it here. View, we can, our data view, text to column. Have you seen the coordinates? See, X, these are pairs, these are pairs. Have you seen it? So you can actually use this now for your boundary. Now look at this. Have you seen the distortion here? There are no pairs here. So now, if you want to make your map, what are you going to use? You're going to use this. So this is what? What? Yes, it's 4. Definitely now it's 4. It's 4. This is 5. This is, yeah, if you want you can still make this one, but this is 4. You're actually dealing with the 4 coordinates. You understand? You're actually dealing with 4. But if you look at there here now, you find out that these coordinates are uniform. Compared to this. So by way doing using this method, you've actually corrected this. You know, the bigger the area, the bigger your distortion. The smaller the area, the smaller your distortion. You get it? Do you have any question? What do you want to say? Yes.
After changing it to
Yes. The essence is you are given a coordinate in WGS and you want to now work in UTM. When you now transform it, because the edge is not perfect square, edge is spherical, at the north there are some changes. Do you understand? So whenever you now change to metric from degrees, you will have distortion. There must be different because they are changing from one coordinate system to another. Now, for you to have a perfect numbers, edges, what do? The only way to do that, for you to have that perfect, is for you to have a perfect rectangle. That's why I brought it from the other application to AutoCAD, because AutoCAD can draft very well. You understand? Now, what did we do here? We just simply drew rectangle from the other first edges to these edges. Because for you, in degrees, this is actually supposed to be the right rectangle. But because you've actually transformed it to UTM, you find out that this rectangle is no more longer a rectangle. There are some distortions along the way. That is the essence. Irrespective of where you're getting the coordinate from, but whenever you are given a coordinate from degree and you want to work in UTM, note that this will actually happen. You must have some differences as a result of projections. You get it? So, in your daily activities and all that, you are supposed to understand it and supposed to make use of and understand that yes, you might have some changes whenever you are doing changing from that or that. Some people will ask me, why is it that when we change to this, the lines will not be straight again? The lines are no longer like the way it was. This is just as a result of projection and reprojections from one to another because of the shape of the egg.
okay, so that projection just simply changing from one to another.
Yes, the projection is just changing from now. What has actually happened is that there is what we call WGS is a joint, is a universal dating used worldwide, is a universal dating. Now, every other work, most of the work that is done universally is done in WGS 84, is in degrees. You understand? Now, because the egg is spherical, you understand? Not a perfect square anywhere. So, as you are going to the pole, there's so much distortion. That's why when you go to the pole, there are different projections from one area to the other based on where you are. Do you understand? Because this is now we are trying to bring degrees to metric system. You get it? So we are trying to bring degrees to metric system. Because of that, it's just like imagine when you have a circle and you want to take this circle, you want to draw linear lines along the circle for you to have the diameter of the circle. You want to stretching the circle. So at every point in time, the more you go, the more it changes in circumference. So because of that, there must be some changes. So people at the middle might not have much changes. The same thing happened to magnetic system. When you're talking about people at the pole and the people at the equator, they are not the same. They are not the same thing. Magnetic differentiation are not the same. They are not differential. Sorry, are not the same thing all over. So that is actually what you experience. So when you're talking about projection, you just simply mean from one system to the other based on the actual location where you find yourself. We've made a video on this now. I made a video on projection. the projection and projection. You understand? We've done that before, so you can check it. Thank you.